This is a Technicom podcast.
Have you heard of mixed reality? Sure, you may have heard this phrase thrown around here and there, but what is it really, and how can this technology benefit you? I'm Peter Ballant from Technicon, and today we introduce the REALHOLO project. In this European H2020 effort, project partners are aiming to move mixed reality in the direction of, well, reality. And to clarify, mixed reality is the blending of the physical world with digital objects. In this environment, real and cyber objects coexist and interact in real time. And the only way to effectively do this is by using holography. And this is where REALHOLO comes in. Scientists are working on using micromirrors to project these lifelike holographic objects. It's no easy task, or even easy to understand. But to help us along today, we welcome Hagen Stoller and Johannes Pleikes from C-Real Technologies in Germany, whose mission is the development of holographic 3D displays. Let's have a listen. Welcome, gentlemen, to this podcast about REALHOLO.
Thanks for asking us to join.
Yeah, thank you.
Tell us about the overarching mission in REALHOLO, and we'll start with you, Johannes.
Yeah, so the mission of the REALHOLO project, one can summarize such that we are developing a display technology for mixed reality displays, which can be called real holographic. Mixed reality in general is emerging technology with a lot of promising applications that can connect computer-generated content and human perception. And in the scope of mixed reality displays, that means the display can allow to show content as it is naturally seen by the human. So that means there are depth cues that the human is used to see in the real world, and that should be available also in mixed reality displays. And in REALHOLO, we will get a step further in allowing to reach such ideal mixed reality displays. And the main objective of REALHOLO is the development of this new type of spatial light modulator that will allow new types of mixed reality displays which have new and extended feature sets. Hagen, what do you think? Do you want to add something on this?
Yeah, Johannes actually explained it quite well. But what one could say to provoke the imagination, what does a modulator do when it does phase modulation of light, because people may hesitate and think about what is phase modulation. You could say that a normal display like you have in your mobile phone or on your desktop only modulates the brightness in each pixel, which we call the amplitude of light. And if you compare it to waves, or you can use water waves if you want, so it would be the height of the waves that you modulate. But what we also modulate in a hologram is the timing of these waves, which is called the phase. So we don't only control the height of the waves, but also the timing of waves. And then you can imagine, or may even remember from your physics schools and class in schools, you could say, okay, if I now modulate the timing, the phase and the brightness of each pixel, I can actually decide how the light interferes when traveling to your eyes. And then you can imagine, okay, if then the light waves interfere in space, these little 3D objects are created in real space and not on a flat display. So the whole principle of holography is different from typical standard 2D displaying. So this makes a whole difference. And this micro display that we are developing actually enables very clean modulation of these phase values by my micronic movement of little mirrors.
Okay. And to go back briefly to this idea of mixed reality, some listeners may have the idea of virtual reality and maybe mix up the two. In mixed reality, we're sort of merging the real world and the virtual world. Is that correct?
Yeah, I agree. So there are different terms like mixed reality and augmented reality, etc. So mixed reality, I would mix real life content or real life objects with virtual objects. And the really cool feature of real holography is that the virtual objects are placed right next to the real objects. And if you look at them, if they're perfectly done, you cannot really differentiate between them if the holograms are really well done. And then if you look at them, your eyes really get the same information as they receive from the real object. So you can focus on these objects. If you move a little bit in space, left and right, they move relatively to their peers in space, virtual or natural. And this is really what makes a real hologram, that the objects behave the same as their real life counterparts.
Now, Hakan, I want to ask you, as a company, which, as I mentioned earlier, you're working for and representing C-Real in the project. Tell us a little bit about what your company is doing for REALHOLO.
So C-Real has been working on such kind of technologies for many years. So we have expertise and experience in holographic display technology. The whole range from hardware development to hologram computation in real time. And we are applying the solutions that we generate in the scope of REALHOLO. So we have working prototypes that use holographic principles. So we can already show that the concepts of real holography work. We just want to make them better and bring them to a commercial level with these new components.
So it sounds like C-Real is a perfect partner because you have the experience to really push this thing forward.
Yes, we would tend to agree. So we focus really on real holographic 3D solutions. So this is our main purpose of the company. So this is like our home field. We really love doing this, and this device that is being developed is perfectly suited for our applications. And then it doesn't really matter if it's in which space you use this. If it's really, we aiming at 3D displays, but you could also use this in other applications, as ranging from scientific instrumentation to astronomic devices, etc. But we are focusing on the real 3D display devices.
We've done a lot of talk about 3D and holography, Johannes, but I have a feeling that there is some misuse when it comes to these two terms. And I think you would agree. Tell us more about this.
Yeah, Peter, you're right. So quite often in marketing messages, one can find especially the word 3D and together with display, and quite often they are even called holographic. But quite often they are quite far away from the real holography as it is set by the physics. So holography is generally considered as the gold standard for 3D displays, and therefore this term is quite often used for marketing purposes.
So 3D is not always 3D.
Yeah, that's true. So quite often it's just 2 dimensions and a little bit more, but not.
We would say it never is 3D before you really make a holographic display. Maybe we are a bit biased, but in principle, whatever you see on the market is not really 3D.
So basically, in real holography, the wavefront of the light is modulated such that one can see the scene as it would really appear in real life. So basically, your eye can focus on one part of the scene and the other parts which are maybe at a different depth. So, for example, you focus to something which is in touching distance, and then the objects on the horizon will focus. You can decide yourself where to look at, and the display doesn't even change information. Still, one can concentrate on different parts of the scene, and that's exactly what is also happening in real life. And with such a display, one can generate the same perception. Yeah, and this features are very important for mixed reality because, yeah, of course, they should integrate as good as possible into the reality. Yeah.
And that's the goal of RealHolo. And I wonder, Hagen, which industry is screaming the loudest for this technology that you're developing in RealHolo?
The use of real holographic 3D displays is driven by content, of course. I mean, you need to have something to show on the display, but there's a lot of 3D data out there. But it's also driven by early use cases and somebody daring to start with it. So, of course, there's a big market of augmented reality and mixed reality, but making a mobile display is quite challenging in terms of power consumption, etc. So we are quite happy to have this partnership with the automotive partner, Volkswagen, the largest car maker in the world. So it's a nice starting point for us. And they want to use this projection device or the holographic projection system for head-up displays to show 3D information in front of the driver or of the co-driver, the passengers. And there are cars with head-up displays today, but they are all 2D displays. So you show a 2D plane in space somewhere in front of the driver for showing the speed of the car or navigational information. But with the holographic display, you can really show these in proper space. So which means you can show the navigational error at the street corner where you want to take a turn, or you can show point of interest to the driver to say, okay, that's where I'm going to shop, or that's where you want to exit the car. If it's even autonomous driving, you don't need to grab the steering wheel. You could just watch where you're going and things like that. So they are really interested in this type of application. But of course, you could also use this for other applications. And I think one of them may not be as obvious, but if you think of a front projection, like the video beamer you have maybe in your home theater or on the movie theater even, you can increase the contrast or the black levels, which is called high dynamic range. So you can really make the images popping more out, by just making sure that it's a 2D projection in a home theater, but the black levels, are just created by blocking some light. But if you use this RealHolo device inside the engine, then you could actually ensure that the pixels that are supposed to show a dark range in the night sky don't get any light. So then the contrast of your 2D projection becomes much, much better, and it becomes so much nicer. So there's even outside the real holographic display space, there's a lot of applications that you could use this device with.
Uh-huh. But it's mainly driven by the automotive industry, is that right?
Yeah, we are starting in the automotive industry, and this is really a cool application because right now, you sometimes even with a head-up display, you don't have to look down at your navigation system. You just look in front of you, but the navigation arrow is still pointed somewhere in the fixed distance today because that's the fixed distance of your 2D projection head-up display. And you may still wonder, am I taking the turn on the second or the third street on the right? Because the arrow is in a fixed distance. In a holographic display, this arrow is pinned to the street corner, and while you're driving, it stays there, and you know exactly where you have to take a turn.
So it's as if the arrow is actually there. I mean, that's the way it looks to the drivers. It's this arrow in the street saying "turn here."
Exactly.
Yeah, nice. So Johannes, back to the project. When you are moving towards completion, there will be a demonstrator. Can you tell us a little bit about what that demonstrator is all about?
Yeah, first we are going to develop the SLM, and then we are going to demonstrate it, as you pointed out, but not only in one use case demonstration, but in two. And the first use case demonstration was already mentioned by Hagen. That's the case of a head-up display for the automotive industry. There will be several different use cases within the car for showing information to the driver, and these will especially change in the future when autonomous driving is more and more developing. Then there will be the second demonstrator, which is not directly the mixed reality, but more structured light projection system. We are going to build an active headlamp, which is using this SLM for projection on the street. So also for automotive use case, some headlamp that can show some information on the street. And so here also we are looking for automotive market, and we have two future trends here also in focus. So one is energy efficiency. And the second thing is that there might be some communication needed between an autonomous car and some human traffic participants. And such an active headlamp might be used for such a use case. And
yeah, actually, what I could add is that we are, on one hand, really excited to work on making this new device because it will improve the quality of holographic image generation significantly. But on the other hand, we want to demonstrate that it really works well and to show the improvement. But the project is quite complex. So to make such a device, very high resolution, high speed, high precision is really a challenging project. So we have to make sure that we use our budget accordingly. So only whatever 10% or so, maybe a bit more, is left for the validation in our head-up display setup. But the good thing is that we are working on such optical solutions anyway. So what we can do is that we can use some of our know-how and experience from head-up display development and replace prior art modulators with the new device and directly compare the quality improvements. So which makes our lives much easier. So we can show the improvement rather straight away with minor modifications. And I think this is a nice advantage that we can focus all the effort in this project onto really making this new device.
Yeah, and Hagen, this is incredible technology that for some might sound a little bit like science fiction, but what is the reality in terms of when we might see these technologies in our world?
This is a good question. We want to get our hands on really devices that use this technology. And we really love working on this automotive project because we think it's really well suited for these new features. If you can imagine, projecting objects really onto the street in front of you in the real positions. But unfortunately, automotive projects typically take a few years more than a normal project because you have all these safety certifications, environmental tests, and things like that. So a head-up display in an automotive device or an automobile may actually take up to 5 years. So it may be 26, 27 when we see this in an actual car, which is quite long. Other applications where this device can be used earlier is for instance, front projection to increase the HDR quality, high dynamic range image quality, increasing black levels to make front projection really more high quality and more comparable to these large flat screen displays, but even at larger sizes. So the REALHOLO component, the MEMS device, the phase of light modulator, how we call it, is really a projection engine that can be used in the automotive space, which takes at least 5 years to bring to market, but also in the front projection quality improvement like black levels and HDR image quality, which may take only 2 years or 3.
So the good news is there's really cool stuff happening, and we just have to be patient a little bit. It's coming.
Unfortunately, yes, but we are working hard on it.
Johannes, I want to ask you, this project has been underway for a little less than a year now, and that means you're about a quarter of the way through. But have there been any unforeseen challenges?
Yeah, Peter, that's a good question. There are challenges indeed, but until now, I would say we didn't find any real unforeseen challenges. So we have been preparing the project for some time already with the project partner from Fraunhofer, IPMS. And so we can say that our initial plans were quite well thought of. And therefore, we did not really find large blocking points or anything that seemed too ambitious in this phase of the project until now. So I would say we have some work to do, but we would not see it very critical challenges.
Yeah, Johannes, you could actually say that we had a bit of a running start, unfortunately, because we had some pre-studies and smaller projects with some of the partners before to make sure it's really feasible. So we learned a bit before to make sure that it's really possible, but it's still quite a challenging project. Because if you just imagine what the precision of these devices has to be, it's quite mind-boggling. Prior art micromirror devices only switch the light in each pixel on and off. So it's basically two end positions and flipping back and forth between those two positions. You can imagine it's quite easy and still hard enough to do this at high speed. But we are switching these tiny mirrors with 250 different positions. And the total range is only 250 nanometers, so a quarter of a micron, the total range. And we split this up into, it's actually 125 positions approximately. So we shift the mirror with increments of 2 nanometers or 3 nanometers, which is really amazing that is technically possible. So this is actually what we had to validate. This is really possible to do these fine adjustments with an electrical drive and with a certain mirror quality, planarity, etc. And the springs that are helping to push this up and down have to be of a certain precision. So each mirror in the big array does the same job, sees the same voltage and does the same movement with this voltage range. So this is part of the challenge to make sure this really works homogeneously across a whole array of many millions of mirrors. But we have a good partner, Fraunhofer IPMS, who has been working on such technologies before. So we are scaling this. And so it's a lot of hard work, but we are confident that we can get there. And also the electrical side, the driving the voltages to these mirrors, of course, has to be of similar precision to make sure that each pixel gets the right voltage, no matter if it's in the left corner or the right corner of the display. So this is a lot of hard work with very fine precision. But we are confident that we get there. And the first year of development actually didn't bring up any reasons that we are not able to achieve this. So this is quite nice to be still on the path to our target specification.
Yeah, that's actually really encouraging. So this is our first podcast in REALHOLO, and I'm certain that at some point we will come back just to get a little update. But for now, I want to say thanks for this really great introduction to the project, and we wish you much success as you move forward on REALHOLO.
Thank you.
Thank you very much.
For more information about REALHOLO, go to realholo.eu. This project has received funding from the European Union's Horizon 2020 Research and Innovation Program under Grant Agreement number 101014977. This project is an initiative of the Photonics Public Private Partnership.